Hi all, let us try to attempt these A-level questions which is related to kinetic theory of gases. For questions 1, in a period of 1 second, 5 times 10 to power 23 nitrogen molecules strike a wall with an area of 8 cm square. If the molecules move with a speed of 300 meter per second and strike the wall head-on in the elastic collisions, determine the pressure exerted on the wall. Given the mass of one nitrogen molecule is 4.68 times 10 to power of negative 26 kilogram. For step 1, we're going to find the force exerted on the wall, where it is equals to rate of change of momentum. The question is without figure, so we don't know whether the wall is on your right hand side or on your left hand side. If the wall on your left hand side, the initial speed is going to be negative 300 meter per second because it is moving towards left, and the final speed is positive 300 meter per second with the same magnitude but in opposite direction. The opposite direction is towards right hand side, so it's going to be positive 300 meter per second. You are going to use the same technique if you choose the wall on your right hand side. This is going to be your initial speed and this is going to be your final speed with the same magnitude but in opposite direction. And for the step 2, we're going to substitute all the values into this formula where force is equals to the rate of change of momentum. By change of momentum, I put it into modulus form to find the magnitude force. So you have two options. One is left hand side wall or right hand side wall. You're going to get the same answer, 2.808 times 10 to power of negative 23 Newton for the force exerted on the wall or magnitude force exerted on the wall. And for the final step, we're going to find the total pressure exerted on the wall by 5 times 10 to power 23 nitrogen molecules. Pressure equals to force per unit area. We're going to substitute all the values accordingly into this formula. We're going to get pressure for one molecule as 3.51 times 10 to power negative 20 Pascal. And the total pressure exerted on the wall by 5 times 10 to power of 23 nitrogen molecules times 3.51 times 10 to power negative 20 Pascal is about pressure for a molecule exerted on the wall. Then you're going to get the total pressure exerted by these number of molecules is about 17.6 kilopascal. Simple like a bubble without giving you any trouble. Questions number 2 is about initially the root mean square speed of an atom of a monoatomic ideal gas is 250 meter per second. The pressure and volume of the gas are each double while the number of moles of the gas is kept constant. Calculate the final translational root mean square speed of the atoms. By using the formula of pressure equals to 1 over 3 times density times mean square speed, where m is remain constant for pressure, volume and mean square speed. According to the questions, final pressure equals to twice of initial pressure and final volume is equals to twice of initial volume. By substituting all the values accordingly into this formula, and finally we will get the root mean square speed of the atoms is 500 meter per second. For questions 3, given that the root mean square speed of a helium atom at a certain temperature is 1350 meter per second, determine the root mean square speed of an oxygen molecule at this temperature. The molar mass of oxygen is 32.0 gram per mole and the molar mass of helium is 4.00 gram per mole. To find the root mean square speed, we have 3 options. We can use these 3 formulas. Because of molar mass of oxygen and helium is given, we can use this formula to solve the problem. By using the root mean square speed, which is equal to square root of 3 times molar gas constant times absolute temperature and divide by molar mass of helium. We can substitute all the values accordingly to find the absolute temperature T, which is equal to 292.4 Kelvin. And we're going to substitute this temperature into the same formula, but now we're going to use the molar mass for oxygen. And we can find the speed of an oxygen molecule at this temperature of 292.4 Kelvin, which is equal to 477 meter per second. Simple like a bubble without giving you any trouble. Thank you for watching this video. Thanks a lot and thank you to the Lord.